Hello, today's subject is interior finishes, and I'm sitting in a wheelchair. All the buildings that we build should be made in a way that people in wheelchairs are able to use them. And the type of surface that I'm going to create on the floor is going to be very important for this. Normally the floor is what is most solicited, and I could take, for example, a floor material and put it on the walls or on the ceiling, and because I'm not using the walls as intensely, this wall here could be covered with lime stucco. Quite often it's not easy to know what is behind this white plaster or stucco on the wall. Here it seems to be heavyweight construction. Over here this wall is a lightweight construction. Drywall, and the ceiling is a suspended ceiling as well, although it has the same look as the massive wall here behind me. In terms of interior finishes, I'm standing on a natural stone floor. Behind me we have an apparent in situ concrete wall. We have a ceiling here made out of wood sections, and I can see the load-bearing structure of this gallery here, which is made out of metal. This box-like structure here out of gypsum board hides very meticulously planned installations. So take another look at the bricks here, where the vertical joints are left open. And another method is this surface here, which has a wood siding, joints left open, black fiber fabric behind it, and behind that black fabric there would be insulating material once again, as to absorb the sound waves coming back to you and hampering with the direct sound from my voice, creating disturbances. Screed, which is isolating the surface I'm walking on from the load-bearing structure, could be covered with all types of materials, for example ceramics. Here this is especially resistance to sliding, and here another pattern, or it could be covered with organic materials. In bathrooms we have easy to clean surfaces on the screed, on the floor, on the walls, and only the ceiling, where no humidity would come, is finished in gypsum board. Then I could use ceramic tiles, which are able to take water without showing stains or signs of use. Once again, I'm standing in a totally white environment, but this sounds hollow, and as we can see, it is hollow, and there is metal profiles suspended with these rods here, and inside I can have all types of installation, in this case electrical installation. This wall looks solid to you? No, it's a shaft, and the shaft is equipped with a sort of structure out of metal profiles, and these are covered with gypsum board, and then the installation shaft can be accessed by these traps being made out of plastic as well. I'm standing on a granite floor. You can see the granite tiles, and here on the other side of the interior non-load-bearing separating glass wall, there's rubber tiles on the floor. So that's a plasto, elasto material, and here we have a very hard, brittle material. On the ceiling, you have a standard tile-based metal suspended ceiling in the corridor, and over here you can see the bare floor slab, and below that we have acoustic plates suspended, so that still can be seen how they are suspended. So this type of surface here could be on the wall, but in this particular case it's a handrail. So the same material can be used for the handrail as for a wall cover. But the wall behind is apparent visual concrete to create a more general aspect to it. Standing in another corridor, you can see that natural stone and linoleum altar on the floor. The walls are made out of brick, although they seem to be non-load bearing, because here's an apparent reinforced concrete structure, which has then been covered by a lime-based color, the same way as the non-load bearing wall infill. And the real load is taken down by these cruciform columns here. So all the interior finishes here seems to be non-load bearing. As you can see here, the architects have been inserting PVC surfaces inside sort of polished screed, and the screed is separated by these silicone joints, and here we have the separation with the aluminum profile. This aluminum profile then can be sanded down to the height of the screed. So at these places the screed has been covered by an epoxy paint because the quality of the screed seemed not to be sufficient. In the case of this wall, you can see the size of the formwork panels and the screws that are holding the formwork panels together. You can also see the mark left by the cleaning machines here on the wall. Now we can decide whether we like the plinth better or whether we like the mark better. Personally, I prefer the mark. Here the interior surface is an aluminum panel. The aluminum panel is glued on a support, and then this support has been fixed to the concrete load-bearing structure. Below me we have two pieces of screed here separated by artificial stone band that marks the accesses of the building. The interior surface has been covered with corrugated, I think it's aluminum plates, and these plates are fixed here visibly, and there are holes inside as to have an access to the acoustic material behind it. That's normally mineral wool that is accessible through the holes to increase the surface that is absorbing sound. You will remark that my voice sounds very dampened right now. Another perforated materials with sound insulation behind, but be careful, students are born vandals, and you can see that this material isn't rigid enough for the type of solicitation that a university building brings. So here you can observe that the same material has been used for the floor as for these columns here. So that's possible if I take the higher qualification material, that is normally the one I can work on the walls as well. What seems solid at first is only 2 centimeters plating on the concrete pillar behind it, and this is the same material as has been used on the floor and for the plinth. If I consider that I might have a load-bearing structure which consists of a floor slab and maybe load-bearing, maybe not load-bearing interior wall, and then the underside of this same floor slab, and so I want to use the interior spaces. First of all, I will need a layer to equalize the surface of this floor slab. So the screed here, which is this layer, could be in direct connection to the concrete. It could be separated by a film, or there could be insulation in between the film and the floor slab. Why would I use the insulation? As to provide sound insulation for the impact of my footsteps, so that in the space below these will not be heard. Why would I use something which is directly put on the floor slab? Because I want to put heavy equipment on it, and this heavy equipment weighs so much that it cannot be supported by the screed, which would only be 4 to 5 centimeters. As for the wall and for the underside covered, it could be a stucco, it could be left as is, which in some cases might not be tolerated. It could also be a sort of under construction out of metal or wood profiles, and then I could put an interior surface on this, for example gypsum board. This could be perforated as to give access to insulation material behind this, as to dampen the sound on the inside of the space. And the same applies to the ceiling, where I could have a suspended ceiling. Then this should be mounted on an under construction, and this under construction then can be suspended from the floor slab. And above that I could have insulating material again.